Confidence intervals provide a range of plausible values based on sample data. To understand how to calculate and use confidence intervals, we first have to look at sampling and sampling error. It is common practice to examine a sample group when looking to learn something about a larger population. For example, a study wanted to know the average BMI of students at Made-Up High School. Rather than measuring every student, the researchers select 10 students as a sample of the whole population and collect their measurements. Samples will never be a perfect representation of the population. Different samples will give different results. This is referred to as sampling error. Confidence intervals are used to express an estimate of a population parameter within a calculated range from the mean of a sample. A confidence interval indicates how accurate an estimate is likely to be. Using the example of BMI measurements of high school students, if we were to discover that the mean of the sample was 24 kilograms per square metre, we could calculate a 95% confidence interval that provides us with a range that we can be 95% certain that the true mean BMI lies. The width of the confidence interval depends on two parameters: the size of a sample and the variation within that sample. The larger a sample is, the narrower its confidence interval range will be. In a small sample, we don't have much data to base our findings, and each sample will vary more from each other. A larger sample will provide a more accurate mean of the population and reduces sampling error. If there is little variation within the population, our sample will also have a small variation, resulting in a narrow confidence interval. A more varied population is likely to produce a much more varied sample, resulting in a wide confidence interval. By using the standard deviation in the sample, we can measure the variation in the population. The standard deviation tells us how spread out around the mean the data are. To measure a confidence interval, we first need to calculate the standard error by dividing the standard deviation of the sample by the square root of the sample size. Next, we use a value from the t-distribution table dependent on the size of our sample and which confidence interval we would like to determine. We then multiply the standard error by the t-value to get the margin of error. We can now add and subtract the margin of error by the sample mean to get the 95% confidence interval. From this hypothetical example, we can be 95% confident that the true BMI average for students of Made-Up High School is somewhere between 21.46 and 26.54. The 95% interval is the middle 95% range of the measurement or outcome. This means that there is a 2.5% chance that the true BMI average is greater than 26.54 and a 2.5% chance that the true BMI average is below 21.46. Confidence intervals can be measured in any percentage, but 95 is commonly used as it usually provides us with a figure in which we can be fairly certain is correct, without being too broad to be considered useful. Hopefully now you have a better understanding of confidence intervals and how they can be used.